Let us see the first part, mapping of ocean basins. Oceanic dimensions range from around 1500 kilometers for the minimum width of Atlantic to more than 13,000 kilometers for the north-south extent of the Atlantic and also the width of the Pacific. Typical depths are only 3 to 4 kilometers. So, the horizontal dimensions of ocean basins are 1000 times greater than the vertical dimension. The amount of land above the sea level is very much less than the volume of the sea itself. It is seen from the graph that the average height of land is 840 meters and the average depth of the ocean is about 3795 meters. The world's ocean floor is also uneven. The principle that causes the unevenness of the ocean surface is the gravity. Oceans accumulate a lot of sediments and debris due to gravitative settling. The sedimentation rate of the whole world shows this unevenness also. The actual shape of the earth is not a perfect sphere, it is not even a perfect ellipsoid, but it is an oblate spheroid. If you measure the strength of the gravity field across the earth's surface, you will find local variations caused by irregularities in the crust, which produce an irregular surface called the geoid, which is the actual shape of the earth. To find the surface caused by ocean circulation, oceanographers mathematically remove the sea height caused by gravity and create maps of ocean topography. They then calculate the speed and direction of ocean currents similar to that of the meteorologists using atmospheric pressure maps to calculate the winds. Altimetry is the measurement of the height of the sea surface above or below the reference levels. Ever since people started sailing the oceans, attempts have been made by them to map these oceans. Ptolemy has prepared the oldest map of the earth with the oceans. Modern knowledge of the ocean began with voyages of discovery of Christopher Columbus in the year 1492 and Vasco da Gama after 1497 and Ferdinand Magellan after 1519 and many other people. They laid the foundation for global trade routes stretching from Spain to the Philippines in the early 16th century. The routes were based on good working knowledge of the trade winds, the westerlies and the western boundary currents in the Atlantic and the Pacific. The early European explorers were soon followed by scientific voyages of discovery led by James Cook after 1728, Charles Darwin after 1809, Sir James Clark Ross and Sir John Ross. All of them surveyed the Arctic and Antarctic regions from the Victory, the Isabella and the Erebus. Edward Forbes after 1815 studied the vertical distribution of life in the oceans. Others collected oceanic observations and produced useful charts, including Edmund Halley, who charted the trade winds and monsoons, and Benjamin Franklin, who prepared the chart of the Gulf Stream. Slow ships of the 19th and 20th centuries gave way to satellites, drifters and autonomous instruments for mapping the oceans. The term topography refers to the elevation of a land with reference to the sea level. The term bathymetry refers to the depth of water column below the sea level. Bathymetry also refers to the depth zones of ocean basins depicted as charts and maps prepared using depth sounding techniques. The words bathos means depth, metry means measurement. The measurement of ocean depths in the Mediterranean Sea was started as back as 85 before Christ. In 1872, the HMS Challenger expedition was the first to use fully the methods of bathymetry. The Challenger was the first vessel used to systematically record the information about all the oceans except the Arctic. It also recorded the depths, circulations, temperatures and the organic life. In the year 1925, the Meteor, one of the oldest South Atlantic Ocean expedition, used echo sounders for depth measurements using sound waves. In the year 1950, the sophisticated precision depth recorders were used for measuring the ocean topographic features. Then came the satellite oceanography. Satellite oceanography is a milestone in ocean analysis. The launching of CSAT in the year 1978 was the first oceanographic satellite, revolutionized the measurements of physical properties of the oceans. The launching of CSAT in 1978, the first oceanographic satellite, revolutionized the measurements of physical properties of the oceans. Within a few years, the sea surface temperature, wave height, variations in sea surface contours, ice cover, chlorophyll content and other parameters were measured and reported almost instantly from the satellites. Satellites now observe the oceans, air and land. Thousands of drifters observe the upper 2 kilometers of the oceanic surface. Data from these systems, when fed into numerical models, they allow us to study the earth as an ecosystem. Next comes the ocean bathymetry. Ocean bathymetry was used as the basis to conduct all expeditions and experiments in different depth zones of oceans. The precision depth recorders of 1950s and the multi-beam echo sounders helped to efficiently and accurately map the ocean relief features. A hypsographic curve is a graphical representation of the area of Earth's surface above any given elevation or depth. This may be above the sea level or below the sea level. The morphology of the ocean basin means the configuration of the ocean basins in terms of relief features. This could be analyzed by using these bathymetric records. Great ocean bathymetric mapping, marine explorations and expeditions have provided us enormous data and information about the oceans of the world. The world's ocean floor, as mapped by Bruce Heezen and Mary Thorpe, is presented here. This map shows the spreading zones, subduction zones with their trenches.